What makes F1 front wing testing difficult? Imagine trying to measure how much a wing bends when a car is racing at over 200 kilometers per hour. That's the challenge teams and regulators face with front wings in Formula One. These wings are tiny but mighty, shaping airflow to generate downforce and reduce drag. They help the car stick to the track in corners and slice through the air on straightaways. But because they're so important, teams want to push the limits of how flexible they can be without breaking the rules. The problem is that real race conditions are super complex. When a car speeds around a corner, the front wing faces forces from air pressure, bumps, and high-speed turns. These forces change constantly and are hard to measure directly. Instead, the FIA, the sport's governing body, uses static tests. They apply a fixed load, around 1,000 newtons, which is roughly the weight of 100 kilograms, to the wing while the car is still. They then measure how much the wing bends, and it must not bend more than 10 millimeters. This makes it easier to check if a wing is within the rules, but it's not the same as what happens on the track. Static tests are a compromise. They are repeatable and easy to enforce, but they don't capture the full picture. Wings can pass these tests but still flex more when the car is racing. This creates a gray area where some teams might design wings that look legal in the lab but bend more at high speed. That extra flex can give a performance boost by reducing drag or changing the car's balance, especially in fast corners. To catch this, the FIA has added high-definition onboard cameras to watch wings during practice sessions. These cameras help spot wings that might be flexing too much, but they relying on video evidence rather than direct measurement. Designing a front wing that balances performance, durability, and compliance is a huge engineering puzzle. Teams spend months in wind tunnels and computer simulations to get it right. When new rules come in, like stricter deflection limits, they often have to redesign their wings from scratch. This can take a lot of time and resources, sometimes several months, before they have a new part ready to race. Changes to front wing testing can shake up the racing order. Some teams were already close to the limit with the old rules, while others played it safe. When the rules tighten, everyone must adapt, and the performance of their cars can shift. This ongoing tug-of-war between innovation and regulation keeps the sport exciting and unpredictable. So the main reason front wing testing is so tough is because real-world flex can't be measured directly during a race. Instead, teams are tested with static loads, which don't tell the full story. Wings that pass these tests might still flex more at high speed, giving some teams an unfair advantage. The FIA's use of cameras and stricter tests helps, but it's still a constant challenge to keep the sport fair while pushing the boundaries of aerodynamics.